right, so we're going to continue where we left off with linear inequalities, and now we're going to do systems of linear inequalities. Same exact process, except you're going to have to graph more than one line on the same graph. That's it. Now, whenever you're going to shade your solution, you shade the first one, except you don't shade all the way, you just do a little bit. Just kind of draw some lines. You do the other one, shade just a little bit, just some lines, and then where they overlap, that's your answer. Easier to see when we do it. So here we go. We have two different inequalities here. Make sure you pay attention. These are both going to be solid, so that's good. They're both in slope-intercept form, so just go ahead and graph them. To make our lives easier, I'm going to color code them. I'm going to call that guy red, and you're going to be blue. So I'll start with blue since that's what color my marker is already. -8. That's my y-intercept. Now, if you're having trouble graphing, go back to graphing equations. That's, I think, the third week. That's way in the old stuff. First 9 weeks is the name of the topic. So our y-intercept here is -8. Our slope is 1/2, so I'm going to go up 1, right 2. I could go down 1 and left 2, except that's off the graph, so that ain't happening. And there we go. I did the next one on Cami because we figured out how to make dotted lines. Thanks, Cullen. And here we go. There's my line. Boom. It's solid. We're good. Now, test a point. You know me. I like 0, 0. So is 0 greater than 0 minus 8, -8? Yes, it is. So I'm shading towards 0, 0. I tested 0, 0. It works for this inequality. So blue guy, I'm going to shade blue. So I'm going to get my blue highlighter. I'm going to go this way. I'm going to do this. This is all I'm going to do. I'm not going to fully shade it. So this is the solution to this one. I'm done with it. I'm moving on to red. What's up, red? How you doing? Y-intercept of -1. Slope of -2/3. I'm going to go down 2, right 3. I'm going to do that again. Oh, hey, look, they intersect. And I can't go anymore. Then I'm going to go, I could have also gone up 2 and left 3. So I'm going to do that just so I can get a nice full picture and hopefully I don't miscount. I'm good at that. If I go up 2, left 3, it's right there. Whatever, doesn't matter. I need a red line. I guess I'll do it from here. Oops. Might hope I have a non-horizontal line. There we go. I'll move that thing down a bit. Okay, I can still test 0, 0 because it's not up in there. It's not on the line. I can test it. Is 0 less than or equal to 0 minus 1, -1? No, it isn't. So for red, my answer would be this stuff over here, away from 0, 0. So for red, it's all of this stuff. Notice I'm still going past the line, the blue line, because as far as red concerned, he doesn't care where blue is. Now for my final answer, it's where the two lines overlap. So I'm going to color that in yellow. So you see red's in here and blue's in here. So this region here is my answer. And I'm going to highlight it in yellow. So we need to be perfect, not in the least. But just kind of indicate where you're shading. And there we go. That's my answer, this yellow stuff. The lines are solid, so that means the lines are also part of our solution. However, if we think about it, this part of the line right here is not covered by blue. So this part of red line is not part of our solution. Similarly, this part of blue line is not part of our solution. But all this blue line and all that part of the red line are part of our solution. So all we're doing is the same thing except twice on one graph. Nothing real different there. All right, let's look at this one. And I said we're going to do Cami. Actually, I might do the next one on Cami because it's probably going to take me a minute to open it. Don't even have it in here. But I'll just show you how to do a dotted line on here. So here, line tool, there's a line. Then you hit your select tool, tap that line. Hit the hamburger icon, and you got your dotted line option. You can also put your arrows on there. So that's how you're going to do your dotted lines on Cami. A lot easier than trying to highlight or erase with the white marker, to me anyway. So that's how you do it. I'm going to be working here because this is where all my stuff's at. Okay, I'm going to call this guy red. Call this guy blue. Let's look at blue. It says y is greater than -7. Well, that's easy. We know what y equals 7 looks like. Or y equals -7. That's a horizontal line at -7. And that's blue. So that's right here. Now for this one, if we look, it's going to be dotted. So I just showed you how to do that on Cami. For my application, I do it slightly differently. Dotted, dashed, whatever, it doesn't matter, just as long as it's not solid. Got all kind of options there. I'm gonna go with dashed. And you know, I should put the arrows on there, but I'm lazy, so I'm not going to. I'm gonna lock this thing so it doesn't keep moving on me. Okay. So there is y equals -7. But we got to go greater. You should be able to think about that. It's going to be up here, right? If we plug in 0, 0, well, there's no x to plug 0 in at, is there? So 0 is greater than -7. Yeah, it is. So blue, it's above this line here. So I'm going to do this number. All right, red, you're up. It's in slope-intercept form. Thank you for being convenient. -4 is my y-intercept. Slope is 3/4, rise 3, 4 to the right, 3 and 4. Could have also gone down 3 and left 4, of course. And there we go. This line is going to be solid. So it's perfectly possible to have a solid line and a dotted line together. There it is. Now let's test the point. Does 0, 0 work? Is 0 less than or equal to 0 minus -4? -4. 0 is not less than or equal to -4, is it? So it's going away from 0, 0. It's going down here. So this is red's solution. And if we put those two together, I have a nice teal this time. It's going to be everything between these two lines in this section here. It does include red. That was terrible. I went out the lines. It's okay if you go out the lines, but I'm going to try not to. And I failed. Oh well. So this teal section is our answer. It's between the two lines. It does include part of the red line, but none of the blue line is included because, well, it's dotted, right? We don't include it. It's not the equal to, it's just greater than. So this teal stuff's my answer. And this part of the red line that's above the blue line. All right, let's see if this one's any interesting. I guess I'll do them both. Whatever. These are in standard form, so I'm going to go with my intercepts because they're super easy. X-intercept is 1, y-intercept is -1. On this first one, that's going to be red. 1 for my x-intercept. -1 for my y-intercept. So I can count my slope's 1. So boom, 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 boom. So if that was too fast for you, standard form, x-intercept is c over a. Well, a is 1. 1 divided by 1 is 1. Y-intercept is c over b. B is -1. 1 over -1 is -1. Or you can just kind of think about it. Cover up the x, -1, negative y equals 1, -1. Cover up the y, x equals 1. Well, that's already done. And we can go this way too, putting a bunch of tiny, tiny dots. I can see them. You might not be able to. But now I'm going to graph that line. There it is. However, it does not include it, so it needs to be a dotted line. Let me go ahead and lock this. There we go. Now test the point. 0, 0 is not on there, so I can use it. Is 0 minus 0, that's 0, greater than 1? No, 0 is not greater than 1, so I'm going this way. And this is why I tell you test the point instead of relying on which way is this symbol pointing. Because remember, you can only rely on which way the symbol's pointing if you're in slope-intercept form. Why would you do all that work if it's such an easy one like this? Your choice. Graph it however you want to graph it. Just graph it. So here is red. Now on this one, on blue over here, we got a little issue with the blue. We have a little issue with the x-intercept. 20 divided by 1's 20. That's not on the graph, so I can't use that. Y-intercept though, 20 divided by 4, that's 5. I can plot that. I got 1 point, now I need my slope or another point. Heck, you could point plot if you really wanted to, but I don't want to. I'm gonna get my slope. It's -a over b, so it's -1 over 4. Oh, it's -1 over 4. There it is. Of course, you go up 1, left 4 as well. And there we go. Blue line here. So again, graphing should not be new to you. You shouldn't have to be like, oh wait, how are you graphing that thing? Yeah, you should know how to graph. If you don't, go back and look at previous lessons. Now, let's see, where do we shade? If I plug in 0 plus 0, that's not bigger than 20, so I shade away from 0. Shade this section. Shade away from the origin, because 0, 0 doesn't work. Both of my lines are dotted, so that means neither of the lines themselves are part of my answer. And they intersect in this little itty bitty corner right here. It looks a little itty bitty, but how big is it? Well, it goes on forever, so it's infinite. So it's really, really big section, just little on this graph. That's our answer right there. See, it's got the red, it's got the blue. That's our answer. It's where they intersect and agree. Next. All right. So again, 2 standard forms. X-intercept is going to be nasty. 18/7. I'm not using that. Y-intercept 6. I can deal with that. 18 divided by 3 is 6. Let's go with it. Oh, you're going to be this color. Oh, you're blue. You're 6. So then slope. -a over b. -7 over 3. Down 7. Give me a minute to count. Counting's hard. There we go. Solid line here. We got that equality going on. Equal rights for x and y's. XX's and XY's maybe. Test a point. 0 plus 0 less than or equal to 18. Yes, it is. So 0, 0 works. I'm going to shade towards the origin. It doesn't have to be over exaggerated like that. I'm just being extra, you could say. All right, another nasty x-intercept. 9 halves. I mean, we could do that, I guess, but don't. No, don't do it. -3, though. We can do -3. 9 divided by -3 is -3. So my y-intercept on this red line here is going to be -3. Let me do that. There. -3. Slope, -2 over -3, which is positive 2/3. Right there, there, and off, or go here, here, and off. So there. Good enough. You are red. A little something like that. And I'm just going to move that over here a little bit. I like to have it going all the way through, you know, just in case, you know, it's in this section or that section, it'll be easier to shade. Well, obviously it's not because blue's going the other way, so I guess that didn't matter. But it does include it, it's solid, so that's good. 0, 0, does that work? 0 minus 0 is less than or equal to 9. True. Shade towards the origin. Boom. Here's the origin, so I'm shading towards that, by the way. Now remember, you don't have to use the origin. You can use any point at all, any point you want to at all. I like the origin because, well, zeros are helpful and easy to think about. You could do anything you want, though, as long as it's not on the line. So this teal section's going to be our answer. And it does include these sections of the blue and red lines because they're both solid. So that means anything this shaded teal region would satisfy this system of inequalities. I might be thinking, oh, we did systems of 3 equations. Are we going to do systems of 3 inequalities? Heck, you can do systems of 20 inequalities. They're just the same exact process. Graph, 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 shade, shade, shade. Where they all agree is your answer. The more you have, the more likely you have no solution. Boom, done. Okay, what's next? I think we got a word problem. We do. Before I do that, though, let's talk about 0, 0. Remember, I kept testing 0, 0. What if we couldn't use 0, 0? Let's go over that for 1 second. Let's say red line went through 0, 0. Well, then I'd plug in a different number. For instance, I might plug in 8, 0. So that'd be 16 minus 0 less than or equal to 9. No, it's not. That's false. So I would not shade where this point over here is. I'd shade the other section. So I wouldn't shade below red. I'd shade above red. See, we can test any point we want to. 0, 0 is just really easy. Last one. To raise money to attend Boy Scout camp, Alec is selling popcorn. Small bags of popcorn sell for $4 and large bags sell for $6. He needs to earn at least $300 to attend camp. That's what we're going to do with it. He'll also earn a badge if he sells at least 60 bags total of any combination. Getting a badge for selling popcorn, okay. So first, it's a word problem. It's a system. It's got some variables. Label them, define them. Tell me what's what. You can use X and Y. You can use A and B. I don't care what you use. I'm going to use S and L for small and large. So S is going to be what? Not the price, but the number of small bags. L is going to be the number of large bags. There, I'm going to stick it over there. Just somewhere you can see it, doesn't matter. Write a system of inequalities to represent this situation. Okay, so this one's dealing with monies. See, it's got a dollar sign, and that's got a dollar sign, and that's got a dollar sign. So those go together. So $4 times the small plus $6 times the large, at least, well, can it be 300? Yeah, 300 is at least 300. Can it be less than 300? No, zero is not at least 300. Can it be more than 300? Yeah. So what's at least mean? It means greater than or equal to. Gotta know what your words mean. And that's 300 buckaroos. You'll also earn a badge, so I'm going blue for this guy, if he sells at least 60 bags of any combination. So if you add the small guys and you add the large guys, they gotta be another at least. That's another greater than or equal to. I don't think we've done any other words besides at least, have we? There's at most, that would be less than or equal to. Anyway, get there eventually, I guess. So we got two equations. I misspoke. My bad. My B. Two inequalities, two linear inequalities. A system of them. So write a system of linear inequalities to represent the situation, then graph. All right, so graphing. We got to have the same scale on both. I'm just looking at it a little bit. I don't think we're going to count by ones because it doesn't have 60 squares, and I wouldn't want to count 60 squares. So for the bottom one, let's just hold off on the bottom one. Let's look at the top. Let's look at some intercepts. What are our intercepts? Come here, intercepts. 300 divided by 4 is 75. Okay. So I need to be able to get to 75. 300 divided by 6, well, that's 50. If we count by fives, 75 divided by 5 is 15. Do we have at least 15 squares on this thing? And I don't think we're going to get to 60. So this bottom one, we need 60. Let's see how many squares we got. Positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We got exactly 15. So if we went by fives, this would be 75, so that would be the intercept. What are we going to do about this guy? Let's count by tens. Let's just do tens. See what happens. So each one of these little things, I'm going to say is 10. So now we need to pick eeny, meeny, miny, mo. You're going to be small. You're going to be large. Okay. So what color do I have? I have blue right now. Let me get red. So these are counting by tens. So 10 to 150. I'm guessing this has the same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So yeah, counting by tens here. So it might be a little off. We'll see. So red line. I forgot what my intercepts were already. 300 divided by 4, 75. 300 divided by 6, it's 50. So 50 is pretty easy to do. Let's do 50. Large. So my large intercept is 50. 1, 2, 3, 4, 5, right here. My small intercept was 75. Got a little issue there. I'm counting by tens, right? 10, 20, 30, 40, 50, 60, 70, 80, 70, 80. It'd be right here in the middle, but we don't like fractions. So there-ish is my intercept. Let's find our slope. -2 over, sorry, it's -4 over 6, which is -2 over 3, right? -4 over 6. Yeah, it's -2/3. Well, I sure can't count by 2s and 3s on here. What am I going to do? Oh, multiply by 10. That's the same as -20 over 30, right? -20 over 30. There's my slope. -20 over 30. -20 over 30. And now why am I not going to plot that? This is 0, 0. If I go down below that line, I'm saying he's selling some negative amounts of large popcorn bags. That doesn't make any sense at all. So don't do it. So this is what we're going to do for red. And we're going to stop right on the axis. So make sure decently lined up. So I was a little off with something. It's fine. Right there. That's good. Solid. So does 0, 0 satisfy this? Obviously not. Would selling nothing get you money? No, it wouldn't. So red's out the other side. Now I'm not going to go to the negatives. That doesn't make sense. Don't try and go to the negatives. So red's this way. Okay. Let's do blue. So my S and my L intercept for blue are both 60. So that's easy. Blue. 30, 60 right here. 30, 60. Right. Yeah, 60 right there. And this one's going to be blue. Again, we got a solid line. So blue is all this stuff. So what's my answer going to look like? Well, I'll show you exactly what it looks like. It's going to follow this line along here. And it's got to agree with red and blue, so it's going to follow this red line up here until they intersect. Then it's going to follow the blue line because it can't go past either one of those lines. And it's going to go all the way up, not crossing that. Boom. This is what it's going to look like. That's our answer. All this yellow. So use your graph. Give 2 possible combinations of bags of popcorns that I can sell to 10 campers badge. A million and zero, a 0 and a million, whatever. Obviously that would work. But you know, you can get any order pair in the yellow here. So you could pick, let's say, this order pair right here. That'll work. But you're gonna have to count. I'm gonna go backwards. 140, 130, 120. So 120 small bags and 10, 20, 30. 120 small bags, 30 large bags works. You can pick anything. You could pick 150 large bags and 0 small bags. You could even go up further if you want to. It doesn't matter. It doesn't matter. Anything will work. That's in this shaded region here. Okay, that's it. Done. Goodbye.